The event today is an open house, and it's intended to celebrate Public Power Week. Public Power Week is a nationwide celebration of municipally owned public power systems. Here locally, we're hosting the open house, and being municipally owned, we feel we've got a special role to play in our community, and we invite our customers to come on down. We've got refreshments, we've got food, we've got bucket trucks, and some giveaways, so come on down. The utility has its roots in the 1890s as a private public power company. It evolved through the years, and in 1913, the city of Wisconsin Rapids floated a bond issue and purchased it from the privately held owners. So the utility has been a municipally owned entity for about 100 years now. This particular site that the utility is located at, the main part of the building, which we're looking at here, was built in the late 1950s, and it's been added on to at least twice that I know of.
Okay, this is a presentation that we take into the schools to show and teach kids about electrical safety, what to do and what not to do. It kind of gives them a visual as far as sparks and arcs and all those great things. What we do is this represents an underground transformer. If it's ever open or unlocked, we tell the kids to never go inside, never touch anything. There will be a sticker on it with our phone number on it to call that phone number, or if they can't get anybody there or they can't find anything, even if they have to, call 911 to somebody to come secure it, because God forbid we wouldn't want them to go inside and receive a shock. Same thing with this, represents a substation. If there's ever a gate open or it's unattended with a gate open, to never go inside, because if you go inside you never know what might be energized. Same thing, it shows the kids kind of arc and spark. This represents, we don't have much around here, but this represents a sailboat. There are power lines over water, so a sailboat could come in contact with the power line and short out. So this represents what we call a transmission line into a substation, back out onto the distribution system, through the distribution system into a transformer and into a house. The voltage on the transmission, we have some in town that's 115,000 volts, and we have some that are at 69,000 volts. The west side is fed by a 69,000 line, east side is fed by a 115,000 line. It in turn then goes into a substation, back out onto our system at 7,620 volts phase to ground, 13,200 volts phase to phase. And then it goes through a transformer into a house at 120/240. And that's the usable voltage in most homes. Businesses, some businesses are 277/480, but that's a business voltage. Also here, this represents anytime you dig, there's underground lines that feed the transformers and the underground distribution system, and it just shows that the kids that we can, just by digging in the ground, come in contact with wires. This represents a person flying a kite. We kind of use the motto of look up and live, so it just gives them a good visual. And this one here, we don't have much anymore with this, but TV antennas on top of houses or towers, people would tip them up and not look up and come in contact with the power line. That is basically what this represents, and we take this, like I said, into the schools as a learning tool and a safety. A lot of schools use it in their science project or science when they get into the electricity portion of their science. So that's pretty much it.
With this piece of pipe is one of the newer water mains that we put in. It's ductile iron. We actually put this in, has been used probably since the 1950s. Before ductile iron pipe came around, we had cast iron. And then before that, they used to lay wood water main. And what wood water main was a piece of pine log with a hole drilled all the way through the center and a piece of galvanized pipe in the end driven in so we can connect one to the other. This piece of pine is probably over 100 years old. It was found down by the old Labor Temple, and it was dug up. It was not in use now, but it was still in the ground as we're replacing that water main there this year. They'd make actually taps, drill holes, and for city and house services to come out of this and hook a pipe up to that as well. Over here we got a water meter. That's a 6-inch water meter that came out of Ocean Spray. It seen its service, and I think it was put in 2006 and taken out at 2013. A lot of water went through that particular meter. So we can continue up to the water treatment plant right now. This is our backhoe loader tractor that we use for water breaks, replacing hydrants, water services. The line crew, linemen actually use it as well. It's a useful piece of equipment, nice and expensive, but it's got all the features that we need and that we can use in emergency situations, along with dump trucks and other service trucks that we use. This is a map of our electric system and where things are and how much power is on each line. We got a pretty vast area. We picked up Buren just recently, as well as we serve out to North Road, Redden Road, south towards Sportsman's and Tractor Supply. And we actually go out into Kellner with our power, so quite a vast area. All right, welcome to the Wisconsin Rapids Water Treatment Facility here at 221 16th Street South, Wisconsin Rapids. Today we're having a tour of what happens and how you get your city water. Our city water comes from 4 Rady type wells. They're a collector well and 1 drilled well. These wells are located in Grand Rapids, 1 on 16th, 1 on 2 Mile, 1 on Airport, and 1 on Griffith Avenue. These wells are designed specifically for high capacity wells, and it's built like a cement silo. They're actually 14 foot in diameter, 70 feet to the bottom. In this well on the bottom there are usually lateral pipes that come out, and they're actually a screened type pipe, and it allows water to fill this cavity up about 2/3 full of water. The static water level is probably about 20 feet down to 30 feet down on most of them. The water that's in this well, we pump to the system, or called raw water, and we pump to the treatment plant here through 2 pumps, a large and a small, and those are centrifugal pumps with casings that are placed actually right down into the well. At the well sites, we inject chlorine gas to sanitize the water, and that water comes in through large raw water mains into the treatment facility. This mixing chamber will be removed this year. We're doing a plant changeover, and we're going to use less chemicals. We're just using a simple polymer. But all the city water comes in through a large pipe underground into this mixing chamber. From this mixing chamber, it goes to each one of our clarifiers. And in the pipe that is going to the clarifier to feed it, we inject a polymer at a very low rate. And this polymer helps take the iron out. Right now, the city wells have about 4 parts per million of iron coming in. So there's a little bit of iron, and we have to remove that iron to make it drinkable water that's pure, clear for our customers. The water actually comes into the plant through the mixing chamber here. It goes underground with the polymer and goes into the center of the clarifier. The center of the clarifier, the iron is actually mixed up with the polymer, looks very much red in the iron. What the polymer does, it helps settle out the iron. And how that works is the polymer grabs little particles of iron, and the particles of iron actually fall to the bottom, and they create a flock bed. This flock bed is down on the bottom, and as the water is circulating through the clarifier, the clear water kind of comes to the top and goes into the troughs, which then goes into the filters. Remember, I said the water coming in has 4 parts per million of water, and the water coming through the troughs at the end of the clarifying process is about 0.15 part per million. After it comes out of the clarifier, it goes into our filter beds, which I'll explain to a little bit about water. Now the DNR regulates water quite a bit. Every chemical that's used and all the process that we use is recorded daily and hourly. We do hourly tests at our lab. Our filter plant operator does these tests continuously through the day as we pump water. Okay, we talked about bringing water into the city. We actually do bacteria water tests in our water at the wells and actually at the plant here. We have a state certified lab, and so we're able to process our own water samples. We take approximately 25 samples per month, and they're done weekly, about 5 weekly or 6 weekly, and they're usually done at schools and different residences. They go through a process of incubating the water, heating it up, and seeing if bacteria will grow. These tests have to come back good. They're DNR regulations very tightly, and so every part that we do to take the water samples is critical. We actually do private water testing for well drillers and stuff too, about 1,000 of those a year as well. So remember, through this clarifier, 4 parts per million of iron, actually at the top of the trough here is 0.15, and at the end of the process will be 0.00 or 0.01 iron to the water system. The treatment plant itself, today we're running about 3,000 gallons a minute, and that equals up to about 2.4 million gallons a day through the system. The west desalinators over here holds 194,000 gallons, is 18 foot deep and 45 foot in diameter. It was built in 1947. 1963, they built a new desalator, and excuse me, this one is 18 feet deep. I believe it's 54 foot in diameter and holds 254,000 gallons. Takes about roughly, I guess I was told now, about 300 minutes from the drop of that water to get through the treatment plant down into our clear well and out to pump to the system. It's here. Okay, so the water that has 0.15 parts per million of iron is actually coming through the trough into our filtering beds. We've got 5 filtering beds total, 3 for this is water clarifier and 2 beds for the other clarifier. The water comes through this main trough, incoming, comes in through these stainless steel troughs on the bottom, kind of about in the middle, and comes to the top, goes over the sides, and falls down through the coal and sand filtering media. We've got about 18 inches, 12 to 18 inches of coal, and then about 20 some inches, maybe 30 inches of sand. After the water goes through that coal and sand, it actually takes all the iron out to 0.00. Or occasionally, if the filter gets a little bit clogged, it'd be 0.01. From this filter, it goes down below. There's kind of a voided area, and what happens there is the water has 0 iron, and it goes into a basement called a clear well. It's a storage facility. Storage clear well holds 625,000 gallons. Out of the clear well, we pump that out to the city towers, and we've got 5 high lift pumps that we use, 2 of them of which are, I believe, are 100 horsepower, and it sends it to the distribution system and to the towers. We've got about 161 miles of water main in the city, and about 1,100 fire hydrants in the city as well. The south tower holds 2 million gallons, and that's about 32 feet of water in the tower itself, which supplies us with about 65 pounds of pressure at the household. The east and west water towers that are both blue hold about 400,000 gallons each. Plant runs 16 hours per day, normally, if we have to run more. We do use electric pumps. Should we lose power, we have backup generators at each of our wells that we can utilize as well. There, I think, yeah, last year we pumped 879 million gallons of water last year. Like I say, about 2.4 to, I think our highest warm days are 3.5 million gallons a day. So, city is always using water, and it's safe water, and it's clear, and that's the job we do. Okay, this is our largest Cellator, 254,000 gallons it holds. We got the water coming through the trough into our larger filter beds here. As I said before, the filter beds are made up of coal and sand, doing the same process, and ending up with zero iron, which goes down in the clear well and out to distribution. Filters work exactly the same way. Water through the top comes, or through the troughs comes to the top, goes down through the filter media. There's a lot of iron in the water. That's why everything looks rusty. We do run about 200 hours on these filters before we backwash them, and we actually backwash them with city water to get the iron particles out of that filter bed. And instead of wasting the water sending it to sewer, that water that we backwash the filters with, which is probably, I'm thinking about 30,000 gallons, goes into a retention tank, which settles out all the rest of the flock and iron that we used from concentrate, and we actually let that sit for a period of hours and draw the clear water off the top, introduce it back into the head of the plant to utilize all the water we can. And then we send some sludge iron very concentrated to city sewer to have that processed. Okay, this is our water operator's office here. What he does in the office here is do tests continually. Usually about once every hour, he checks a number of different things, the chlorine in the water, the pH levels, the amount of iron, and how the clarifiers are working, that they are working properly, and the right amount of chemicals are added to it. So it's constantly checked and recorded, DNR required. He actually runs everything from the wells to the clarifiers on the computer, and he can bring up different screens and adjust pumps, incoming and outgoing, depending on the water tower levels. It's all pretty much keyboard automatic, but things do go wrong, and they have to watch for that too. Our operators actually take the calls for out-of-service power and water for 16 hours throughout the day as well. Like I said, the operators do all the water bacteria testing here. They are state certified. Okay, in this area here, this is one of our pumping rooms. There's 3 high lift pumps, pressure pumps that we send out to the towers. The water in the clear well, that's 625,000 gallons, is pumped out to the system as needed directly into the towers. We have another pumping area where we have 2 100 horsepower electric motors on some pumps that supply the system as well. Like I say, we're standing on top of this big storage tank full of water, probably about 10 feet, and the pumps are pumping out to the distribution system.